So let's take a look at what are ellipses and how do we graph them and what's the equation of an ellipse. And then we'll talk about the little detail that an ellipse would have. So let's take a look at what we have here. So let's focus on the equation, this one right here, x squared over a squared plus y squared over b squared is equal to 1. Now that's an equation of an ellipse, and such equation is an ellipse because we have radius in the x direction is a, and the radius in the y direction is b. So if you look at the picture, so this will be the picture of the first equation we're looking at. So pretty much the vertices is always on the major axis of the graph. So in this case, because a is greater than b, that means our vertices are going to be on the x-axis. So this is the vertex a comma 0, and this is the other vertex negative a comma 0. So we have the vertices negative a comma 0. Now it's along the x-axis because a happens to be greater than b. Now this next thing we have for an ellipse is what we call a foci. Now foci of an ellipse are these 2 points right here, and they're always inside the ellipse and they're very close to the vertices. Now how do we find them? Well, pretty much we're going to use a formula. So this is the formula we're going to be using if we're looking for the foci of an ellipse. So that's how we get those points. And the next thing I want to show you is the major axis and the minor axis. So as you can see here, that whichever direction has the larger distance from the center, that will be the major axis. So for instance, for this equation, a happened to be greater than b, so that means this is your major axis. And b is less than a, so that means this is your minor axis, okay? Similarly, the second case is very similar to the first one. The only difference is now this ellipse is a vertical ellipse, meaning it's stretched in the y direction. So your major axis is the y-axis, and your minor axis is the x-axis, okay? And here we're assuming that this condition holds, meaning the component underneath the y variable is greater than the component in the x variable underneath. If that happens, then the ellipse will open in the y direction. And also foci, it's still the same formula. You take the highest number minus the lowest number squared. So this is still the formula. Now the coordinates are going to change because now it's along the y-axis. So it'll be 0, comma, some plus and minus c. As you can see, these are the foci. Now they lie along the major axis. So pretty much you want to remember just one of them, so that way the other one should make sense once you have done enough problem, hopefully. So let's go ahead and do an example. That way you're familiar with how to use this and how to find all of these, a little detail about an ellipse. All right, so let's take a look at our first problem. So here we have an equation of an ellipse, and we want to find the foci, the vertices, and then we're going to graph the ellipse. So if you were to rewrite the equation, this can be written as x squared over 3 squared plus y squared over 2 squared equals to 1. So that means in the x direction, we're going to travel 3 units because the denominator of x is 3 squared. So the distance we're going to travel from the center is 3. And in the y direction, we're going to travel 2 units from the center because this number happens to be 2 squared. So let's go ahead and see how that looks like. So let's say here's our xy plane, and we want to figure out the center. So the center is 0, 0. That is right here. Now in the x direction, we're going to go 3 units. So 1, 2, 3. And then in y direction, we're going to go, in the left, we're also going to go 3 units. That's in the x direction. So these are the vertices because they happen to be the highest length from the center. Now in the y direction, we're going to travel 2 units. So let's go ahead and do that. So we travel 2 units. Let's suppose this is 2, and then this is -2 then. And if you connect them, we create an ellipse. So something like this. So as you can see, our major axis is the one that has the longest length from the center. So that will be the x-axis. So this is the major axis. And then this is our minor axis. Now, we found the vertices. So the vertices are the highest point and the lowest point. So the vertices are, it's along the x-axis, so it's plus and minus 3, 0. Now for the foci, that is found by c squared is equal to, so we do the highest number on the denominator minus the lowest number. So that would be 9 minus 4. So that would give us c squared is equal to 5. So that means c is equal to plus and minus the square root of 5. So our foci, it's going to be the coordinates plus and minus square root of 5, 0. So we can say the foci is somewhere right here. So let's just say that's square root of 5. And that's negative square root of 5. So there you have it. Now, if you want to measure the length of the major axis, we just need to subtract the endpoints. So from here to here, what will be the length? Well, this would be 3 minus -3. That would give us 6. So that will be the length of the major axis. And then the minor axis would be in the y direction. So that would be 2 to -2. So that would be 2 minus -2, which is 4. So that will be the length of the minor axis. And there you have your graph of an ellipse. All right, now let's go ahead and take a look at one more example. So for this particular example, we actually have to write it in standard form. So that way one side is equal to 1. So we're going to go ahead and divide both sides by 144. So we have 16x squared over 144 plus 9y squared over 144 is equal to 1. And now we simplify these numbers. So 16 over 144, well, that will give us 9 on the denominator plus, and then y, okay. So 9 over 144, well, that will simplify to 16 on the denominator. So this is y squared over 16 equals to 1. Now that is the standard form of an ellipse, center at 0, 0. So now we can go ahead and rewrite these 9 and 16. So you have x squared over 3 squared plus y squared over 4 squared is equal to 1. Now, because the denominator of y squared is greater than the x denominator, that means it's going to be an ellipse along the y-axis. So that will be the major axis since denominator of y is greater. So if you draw the x and y plane, your major axis is this one because 4 is greater than 3, and your minor axis is this one, the x-axis. Now let's go ahead and draw it. So for distance in the y direction, so this would be 4 here and -4 here. So these are the vertices. And in the x direction, we traveled 3 units, so -3 here and 3 here. Let's just roughly estimate. And you connect them, you create an ellipse. Something like that. So now our vertices, as you can see from the picture, are 0, comma, plus and minus 4 because they're along the y-axis. And now for the foci, we're going to use the formula. C squared is equal to, again, you will do the larger value of the denominator minus the smaller value. So we will do 16 minus 9, and that will give us 7. And finally, we take the square root to find C. So C is equal to plus and minus square root of 7. So those are the foci, and they're somewhere around here. So those are the foci, F1 and F2. And you can write them as a coordinates. So you have 0, comma, plus and minus square root of 7. There we have it. So another graph of an ellipse along with vertices and foci. Okay, so I hope this makes sense. See you guys next time.